Hello everyone, welcome back. In this video, we are going to learn more about ionic bonding. In my previous video, I mentioned what is ionic bonding and what are the conditions for formation of ionic bond. So we will take one more example to make you understand what is ionic bonding. So example is calcium chloride. For example, calcium chloride. So how will we show bonding between calcium and chloride here? So first of all, we should know what is the atomic number of calcium, which is a metal. So it's 20. Whereas chlorine, which is a non-metal, its atomic number is 17. Now we will write its electronic configuration. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So if we count 4, 10, yes. So this is correct. Then for chlorine, it is 1s2, 2s2, 2p6, 3s2, 3p5. So this is the electronic configuration for calcium and chlorine. Now, as we have seen, calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. So from its electronic configuration, you can see that calcium has to lose 2 electrons to attain stable gas configuration of argon. So by losing 2 electrons, calcium will become Ca2+, calcium ion. Whereas chlorine needs 1 electron to attain stable gas configuration of argon. So it will gain 1 electron. But as we see, calcium is losing 2 electrons, whereas chlorine is just gaining 1 electron. But as I said, the number of electrons involved will always be same. The loss means the number of lost electrons should be equals to number of gained electrons. So what happens is that 1 electron goes to 1 chlorine, like here, and the other electron will go to another chlorine atom, 1s2, 2s2, 2p6, 3s2, 3p5. So to attain stable configuration, so this will also gain 1 electron, this also gain 1 electron, and that's how it is Ca2 plus. So when these two ions combine together, so it forms a neutral compound known as calcium chloride. So the number of electron involved should always be equal. So this is example of ionic bond. Now we will start with covalent bonding. So as I said before, there are two types of bonds between atoms to attain stability. One is ionic bond and the other one is covalent bond. Covalent bonding is always between non-metals. So both atoms of different elements should be non-metals, means which have tendency to gain electrons. Tendency to gain electrons to attain stable gas configuration. So simplest example if I take here is hydrogen and another atom of hydrogen. So if we write, if it's right electronic configuration of hydrogen, atomic number of hydrogen is 1. So the electronic configuration would be 1s1. Similarly for this one is 1. So as hydrogen nearest noble gas is helium, so hydrogen needs to attain only 1 electron to get helium configuration, because helium is 1s2. So each hydrogen needs 1 electron to complete its octet, but here it is duplet. So we write 1 electron showing the valence electron here, and the another valence electron here. So as both have tendency to gain electrons because both are metals, non-metals. So what they do is, best thing is to share. They share electrons so that they can attain duplet in case of hydrogen. So now there are two electrons between two hydrogen atoms, and this sharing of electrons. So sharing of electron between two atoms is known as covalent bond. So there is sharing of electron. There is no gaining, there is no loss. There is just sharing of electrons. So both atoms of elements can attain stability. So we will take more examples. Next is Cl2. For example, Cl and Cl. So if we look at the configuration of Cl, so it's 1s2, 2s2, 2p6, 3s2, 3p5. Similarly, for this chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. So both chlorine atom needs one electron. So as they need only one electron each, so instead of losing or gaining, what they will do is they will share electrons to attain octet or to attain 8 electrons in their valence shell. So this is our last shell. So total electrons here in the valence shell of chlorine, each chlorine is 7 electrons. So we write dot structure. These are called dot structure or Lewis electron structure or Lewis dot structures. So we just write only the valence electron because they are the only electrons which are involved in bond formation. So to share electrons, because both the chlorine atoms need one electron, so in the middle we will write only one electron so that we can show the sharing, and the other 7 electrons would be like 6 electrons would be written like this. Similarly for this chlorine, so total 7 electrons in this chlorine atom and in this. So if we want to show the sharing, so you will see there, now you count 1, 2, 3, 4, 5, 6, 7, 8. So this chlorine atom has attained stability. Similarly, this chlorine atom will attain stability. So both the atoms have attained 8 electrons in their valence shell, and this bond between two chlorine atom is known as covalent bond because there is a bond between two chlorine atoms by sharing electrons. As I said, these electrons, these structures are known as Lewis dot structures or electron dot structures. We will take more examples. Next example is hydrogen chloride. So if I want to show Lewis dot structure in hydrogen and chlorine, as both are non-metals, so first of all we will write electronic configuration. So for H it is 1s1, and for chlorine it is 1s2, 2s2, 2p6, 3s2, 3p5. Similarly you can write for HF, HBr and so on. So hydrogen has 1 electron and chlorine has 7 electrons in its valence shell. So hydrogen needs to complete its duplet, so it will share 1 electron with chlorine. Similarly, chlorine needs to complete its octet by having 1 more electron, so it has completed its octet. So this bond between hydrogen and chlorine is known as covalent bond. Then comes NH3, ammonia. So here the central atom would be nitrogen. So we always write the central atom because there is only one nitrogen and three hydrogen. So nitrogen is surrounded by three hydrogen. So central atom is nitrogen. So first we will write lowest dot structure electron, valence electron for hydrogen, each hydrogen. That's, and for nitrogen it is the atomic number is 7. So 1s2, 2s2, 2p, 2p3. So there are how many valence shell? Valence shell is 2 and the electrons present in the valence shell is 2 plus 3, 5. So each hydrogen needs one electron. So we will write 1, 1, 1 and the rest of the 2 electrons will go here. So how will we show the bonding? Here is the bonding between hydrogen and nitrogen. Hydrogen needs 1. This hydrogen needs 1 to complete its duplet. This hydrogen needs 1 electron to complete its duplet. What about nitrogen? Nitrogen has already 5 electrons. So it needs to share 1, 2, 3, 4, 5, 6, 7, 8. So it has completed its octet. So these are three covalent bonds. Covalent bonds, or we call them, these are electron pairs. Electron pairs which are involved in bond formation. Whereas these two electrons which are not involved in bond formation is called lone pair, not participating in bond formation. So this is one example. So in my next video, I will give you more examples to show the covalent bonding and how will we write the electronic structure, Lewis dot structures for those compounds. Thank you.